So here we have a problem with two different objects moving. We have the woman and we have the bus. Now, what happens is, when the woman is 15 meters behind the bus pulls away. The woman runs at a constant velocity, the bus is accelerating, and eventually, at some point, they're in the same place at the same time when the woman catches the bus. We want to find out how long does it take her to catch the bus. So let's see, we have two things moving, so we need to separate this into two columns. We'll have a column for the woman and a column for the bus. So the woman's givens are here, and the bus's givens are here. Now, we don't know enough to solve for either one by themselves, so we have to relate them. We know that the distance that they both move is related. So let's say that the bus moves the distance x before the woman catches it, and the woman moves the distance of x plus 15 before she catches the bus. We also know that the times are going to be the same. The woman is running just as long as the bus is driving. So now the woman's at a constant velocity, so we use this equation and we can get to here, an expression for time in terms of x. Okay, so let's look at the bus and do something similar. The bus is accelerating. We don't have final velocity, so we use this equation. And we rearrange it, plug in for our delta S. Okay, so now we have two different expressions for time. We know that the two times are equal, so we can use that. So we rewrite our expressions for time, setting them equal, and we're going to do a bit of algebra here. And let's set everything equal to 0 to make it all look nice. And then we have to do the quadratic equation. Here's the quadratic in case you forgot it. So plugging everything in. And we get our two roots. We get x equals 969 or x equals 0.23. Now we have to decide which one makes sense. Well, she's going to catch the bus when x is 0.23. If she kept going and did not get on the bus, then she would pass the bus, and the bus would then catch up to her at x equals 969. Okay, so we want the first one. When she first catches the bus, she's not going to run past the bus. But we're not asking about x, we want to know how much time it takes. So we go back, and we have two expressions for time. We can use either of them. I chose this one. And we plug everything in, and we get this for our time.